Yeah.
Countdown.
Yeah. Hello. Good morning and good afternoon to everyone. Thank you for joining the integrated program of Better Air Quality Technology Roundtable and Fair for Combating Air Pollution and Climate Change in Asia. Together with Evelyn Tamayo from Clean Air Asia, my name is Didin Agustian Permadi. So one of your hosts for this session, Meeting Air Quality Monitoring Technology Needs, where we will hear from the air quality monitoring technology suppliers to share more about their technologies. Ever, please.
Thank you so much, Dr. Didin, for that introduction to our session, and good day to everyone. I am Ever from Clean Air Asia, and I'll be joining Dr. Didin as one of your hosts. And here are a few reminders for our session to guide us before we officially start. So please be reminded that the whole event is recorded via video and chat. You are all requested to send your questions and comments via the Q&A chat box. So it's on the right side of your screen. The facilitators and the resource speakers will respond via chat or live if time permits within the session. Interpretation function is available. So if you look at the bottom right side of your screen, you can click on the headset logo on the lower right, and then you can choose the relevant language. As explained in the morning sessions, you can type in the code Clean Air Asia, and you should be able to select the right language. You can mute the original audio by clicking on the speaker icon beside the translation icon. If there are any problems of any sort, you can also type it in the chat box so that our tech support can assist you. If you're experiencing slow internet, you can click the HD button on the right side bottom of your screen and change it to LD. And also, of course, don't forget to share the event on social media by sharing the hashtag #TechForCleanAir.
Thank you, Ever. So, ladies and gentlemen, in this session, we will hear the important issue of the air quality monitoring. And also, we know that it is very solid and important part of air quality management, actually. So, to kick off this session, let's hear from Dr. Kazuhiro Misaka from Green Blue Corporation. Dr. Misaka is a manager of new business development including GBiot for environmental sensing services and the corporate planning for Greenblue. So he has been involved in multiple projects related to smart home and smart city in collaboration with industry, government, and academia, as well as the projects for each government agency, university, and research institute, leading to indoor and outdoor environmental sensing. Dr. Misaka, the floor is yours.
Hi. Thank you very much for your kind introduction. My name is Kazuhiro Misaka from Greenville Corporation. Thank you for giving me this opportunity to make this presentation. Okay. Okay. The title of my presentation is GBiot, Air Quality Sensor Monitoring System and the Application. GBiot is our trademark for environment sensing. This presentation will focus on GBiot. Please, next slide. No. Sorry. The table of contents of this presentation is as follows. Business overview of Greenblue Corporation, GBiot series, comparison of automatic monitors and sensors, and so on. Please, next. To begin, I'll explain the business overview of Green Blue Corporation. Founded in 1972, Green Blue Corporation is a pioneer in environmental research, environment and, measurement and analysis, environment monitoring, and system development. Its business activities include maintenance and calibration of automatic monitors, development environment information system, environmental research and assessment, environment chemical analysis, and product development sales, and overseas environmental technical cooperation. On the right side, you will find the photo on the considered subject of environment research. Please back. Sorry. Two more back. Sorry. Yes. On the right side, you will find the photo on the subject of environment research. The contents of include PM 2.5 observation of the general environment, as well as environment research on the various objects and location, such as a classroom and other indoor spaces, ships, airports, drone, dioxin, and farms. Yes, next. Next, I'll explain our main business, the development and maintenance of continuous atmospheric monitoring system. We develop and maintain the continuous atmospheric monitoring system managed by the Ministry of Environment and the local government. The page provides an overview of the system. There are more than 1,900 measurement stations like one in this photo throughout Japan, where automatic monitors are installed to measure substances such as NO2, SO2, and PM 2.5. The data collected by the automatic monitor is transmitted through an optical fiber network to the central monitoring station of each local government, where the data is checked, form and graph are prepared, and the information is made public. The data is transmitted to the Ministry of Environment, where air pollution information for entire country is made public in a centralized manner. Next slide. Next, I represent an overview of the GBOT series. GBOT can be divided into the outdoor application. The former includes CO2 monitoring and air pollution monitoring for CO2 and VOCs. The latter includes air pollution monitoring for environment criteria items on vehicle sensors, drone atmospheric observation, and working atmospheric survey model. Yes. Next one. To recognize the use of GBOT, please watch the video to see how GBOT is installed and checked. The video viewing time is about 1.5 minutes. Please video show. Thank you. Next, please. Next, I'll explain the comparison between automatic monitor and the sensors. The photo on the left shows an example of monitoring using automatic monitor, while uh, while the photo on the right shows an example using sensors. In the case of automatic monitor, as shown in the photo on the left, there is usually an automatic monitor for each substance in a container-sized measuring station. The photo on the right showed use of sensor, which allows the monitoring of multiple substances in the space of single pipe. Comparing automatic monitor and sensor, automatic monitor can monitor with high accuracy, but have limitations, such as the need for the measurement site and high cost. While the sensor have a lower measurement accuracy than automatic monitor, but have fewer of these limitations. Please next. This section presents a comparison of data between GBOT and the official method. The two graphs show the data comparison between GBOT and the official method for PM2.5 and ozone. In each graph, the blue line shows GBOT and the orange line shows the official method. The GBOT data is from Saturn University in Kanagawa Prefecture, while the official method data is from a nearby measurement station about 5 kilometers away from the university. The time period of each graph is August. The graph shows that the trend of GBOT and official method data for both PM2.5 and ozone are in good agreement. Next, please. Next, I'll introduce some example of measurement in Asia. As shown in this map on the right, air pollution such as PM2.5 and NO2 are being observed by GBOT in 4 cities in Myanmar. Among them, in Yangon City, GBOT and 2 sets of official methods are being operated in parallel. Next. Next, I'll present an example of practice in Vietnam. As shown in the figure, with the local counterparts, we collect the air pollution data and the video data around the lake in Vietnam, using 3 monitoring stations and 2 motorcycles from September to November 2020. Based on data analysis and visualization, air pollution situation around the lake was graphs. Combine the image from the motorcycle with the PM2.5 concentration gives a good idea of what is the cause the hotspot and where they are located. Next, please. Next, I'll present the practice of AI-based air pollution prediction along roads. We collect the data on the road in Tokyo at fixed time every day, using a monitoring station, vehicle, and pedestrian. Based on these data, short-time prediction along road was made by AI-based air pollution prediction technology. Please, next. Finally, I'll explain things to be considered in system construction and operation. Consideration include location power supply, communication, security, maintenance, and calibration. Typically, among these are for the installation location, the representative point in the area, avoiding the influence of specific sources, and avoiding the influence of air currents, and so on. In addition, although not highly frequent, maintenance personnel are required to replace parts and restart the power supply several times a year. As for routine tasks related to GBOT, it is necessary to check the data, but there are no missing data or other abnormalities. Maintenance that touches the equipment is basically unnecessary. Training is provided through on-the-job training using the equipment and written and video manuals. Next. Thank you for attention. Thank you very much. That's all.
Thank you so much, Ms. Akasan, for that presentation, which has shown the intensive work of DreamView Corporation has done for decades, from reference level to sensing services to air quality monitoring, with even the use of artificial intelligence or AI for air pollution prediction. You may have some questions for Dr. Misaka, and these will be answered during the Q&A, but also you can put them in the chat box, and he will be able to also respond through the chat, through the Q&A box. And next up, we have Mr. Sean Wihera from Clarity Movement. Mr. Sean Wihera is the Vice President for Business Development and Partnerships with Clarity Movement. It's a California-based startup providing next-generation air quality management solutions to cities around the world. Since joining Clarity Movement in 2017, Sean has led Clarity's network deployments into more than 75 cities throughout 40 countries around the world, with numerous government and industrial partners. Mr. Behera, the floor is yours.
Hello. Thank you so much, Ever, for that kind introduction. And a huge thank you to the team at Clean Air Asia, the Ministry of Environment Japan, and the Institute for Global Environmental Strategies for hosting the BAQ today. It's wonderful to be back in touch with this wonderful community. So briefly, again, my name is Sean Wihera. Thank you for your attention today. Broken our agenda down briefly into two parts. One is a brief introduction to Clarity Movement and our Sensing as a Service air quality monitoring. And the second is a brief review of lessons learned in terms of air monitoring and air quality management. So next slide, please. All right, so starting with part one, just this idea of a brief introduction of who we are at Clarity Movement, our work around the world, places like London, Quezon City, etc., and a little discussion about Sensing as a Service air monitoring. So next slide, please. So just briefly, my bio is maybe a little out of date. To date, Clarity is now deployed in over 65 countries with primarily government agencies as partners, industrial users, and community groups across 6 continents. Since being founded in 2014, this has really been a very rapid expansion for us. And the internationalization of our work has provided us with really quite unique experience understanding where and how sensors and air quality monitoring operate and the ways they operate, the pros, the cons, the different challenges of many environments. And of course, that includes quite substantial and increasingly substantial experience throughout Asia. Next slide, please. Some of the government partners, for instance, that we are currently contracted or partnered with include obviously Quezon City, who we've been very fortunate to have partnered with Clean Air Asia and C40. Significant work with the Greater London Authority as the formal and official sensor provider to the City of London, one of the largest implementations of low-cost sensors deployed directly in parallel with the regulatory infrastructure. And we're really going to talk a little bit about that because sensors and air quality monitoring via sensors are not a replacement for regulatory. And I think that's something that we constantly have to reemphasize, is how these technologies work in parallel, not as a replacement for one another. But many of our other partners we can see here, such as the National Environmental Agency in Singapore, the US EPA, etc. So next slide, please. So one of the things that we do a little differently at Clarity Movement that I personally think is part of the success we've had thus far internationally is we don't simply sell sensors. We're not shipping boxes of technology around the world hoping that these work. We actually combine our low-cost sensors with all of our cloud-based software and kind of analysis tools, our Clarity dashboard, so to speak, and consistent project management. People we've pulled from the US EPA and other kind of advanced air quality professionals around the world, and we combine these with every single contract we deploy. So you have not only the sensor hardware used to complement your regulatory infrastructure and answer new exciting questions, we provide hardware replacements for the entire course of the contract. So there's less concerns, not just about what you pay on day one, but throughout the whole course of your contract together. All of the tools to view, to deploy, and to manage your network. And then likewise, not just a technical support line when you have a problem, but we have people there to help you make successes of your technology, understanding siting considerations, calibration questions. How do we adjust for complex source profiles of particulate compositions as they shift through seasons? I often say, when you're building an orchestra, you don't want a violin, you want a violin player. And this is where we really view ourselves not just as a technology provider, but as a partner in air quality management. Next slide, please. So jumping into the hardware for a moment, the core of the Clarity air monitoring solution is really our Node S. This is a self-powered, self-connected air monitor, completely wireless, that takes about 5 minutes to deploy anywhere in the world with a cellular connection. And we focus this device really on measuring particulate matter at various sizes, PM2.5, PM10, PM1, and then nitrogen dioxide. These devices also very importantly measure temperature and humidity inside of the device. So as we think about some of the challenges that trouble low-cost instruments, especially when it comes to accuracy and performance, such as the humidity that we frequently encounter throughout Asia, this is incredibly important for us to be able to adjust, to calibrate, and develop effective correction factors for the device, such that we can maximize their performance and their comparability against regulatory instrumentation, such that we have more confidence in the data and the applications with which we're developing studies and network designs for. I also like to emphasize that because of the self-powered capabilities of these devices, it greatly can reduce many of the other costs of running electricals or trying to get communications out. In the state of California, when the wildfires knock out all of the power systems, we can still collect data in the instances where there's cellular connectivity available. Likewise, through storms and hurricanes, things that would traditionally perhaps interrupt our power systems, they just keep on running. I was just looking at one of our networks deployed in Kuala Lumpur, for instance, back in 2018 during the World Urban Forum 9. And I'm pleased that 4 years later, still getting consistent particle information right off those devices with no interventions. So next slide, please. Now, obviously, PM2.5 and NO2 are not everything that we need to measure. We've really focused on designing the Clarity air monitoring solution as a modular platform. It looks like my animation may have gotten turned into a PDF, so we may not be able to see that today, but I promise it's really cool. But the idea being is that with each node, we're keeping that as scalable and cost-effective as possible, focused on PM2.5 and NO2. But where we wish to add wind speed, wind direction data, add ozone, where we partner with a company called 2B Technologies to bring regulatory quality ozone to our partners, or black carbon, VOCs, some of the additional pollutants that we add in. The idea is that we don't have to have what we don't need when we don't want it or we can't afford it, but rather that we can add what we need, where we need it, when we need it. And this allows us to build networks and scale them together over time as the resources, as the air quality management questions, and as our project budgets and resources simply allow for that. And this is something that, again, we're happy to help partner with you. And I don't want to provide tools if it's not helping solve your problem, or if I can't provide the right quality tool to address a challenge or a question that you have. Next slide, please. So jumping to the kind of software and the cloud-based dashboards, the Clarity dashboard serves a variety of functions: an analysis tool to view all of your data in time series and a number of other statistical formats. We can look at things like deviation and scatter charts, a number of different kind of standard visualizations for how we would be looking at air quality data, comparing it with your regulatory data, which in many places we've automatically pulled from the US EPA, the European Union, etc. And this allows us to provide a lot of the analyses that we may be doing in R or other kind of traditional statistical packages right inside the platform that you already have included with even one single device. Next slide, please. Additionally, in the places where we can pull regulatory data in, it's always key for us. It's not just understanding how did a device perform at commissioning when we first deploy a network, but how is it performing over time? So in fact, when Clarity deploys air monitoring networks, we almost always leave devices co-located with some of the background sites, some of the roadside sites. This way we can ensure that the correction factors that we've developed in one season may need to transition over time. Are we seeing drift in sensors? Can we see transboundary events, whether it's wildfire smoke or Saharan dust blowing into Europe, etc., things that would necessitate a change that we wouldn't otherwise recognize or catch. As a result of your Sensing as a Service partnership and the continuous engagement between the Clarity networks and the regulatory networks, we actually are continually monitoring these changes in performance. And this allows us to be confident in the data, not just from the outset of the project, but throughout the entire duration. And should we identify something that's a question or concerning regarding the quality of the data, your Clarity project team is there to explore it with you and understand what in the context locally or in the terms of the sensors may have caused this discrepancy or this flag in the data. Next slide, please. And then finally, it's obviously not just a question of getting air quality data out of your sensors, but when you're deploying hundreds, thousands of sensors around the world, it's also a question of keeping them all operating. So whenever we're pulling air quality data off the devices, we're also collecting diagnostic data, cellular signal strength, battery charge, any device or air codes that we're getting off the device, all the things that help us not just get huge amounts of air quality data, but ensure that we can manage networks cost effectively, ensure that we can actually trust the data that's coming out of these sensors, that if we see a zero, we understand it's truly a zero and not a device with a clogged air inlet or some other intervention that, or interruption, I should say, that's impacting a device's performance. Next slide, please. It's not maybe the most clever slide, but it does really emphasize, I think, the importance to us that I often say people and partnerships solve problems. Technology just helps. So kind of laughing at some of the question and answer posed in the earlier sessions earlier about the importance of air monitoring. Obviously, it's my job to deploy air monitoring networks, but some of the most success I see is in terms of how we structure partnerships and collaborations. If I think of our work in Quezon City, working together with Clean Air Asia, the Quezon City government, working with C40 and other project stakeholders such as PEMS Technologies, all of these different entities working together in concert has resulted in a much more successful application than simply the singular purchase of sensors and sticking them up on poles could ever result in. So as we think about how not just providing sensors and technology, Clarity is bringing, again, a lot of support, a lot of global experience working with similar problems, similar cities, similar challenges in air quality management around the world, and understanding best how with which we can apply our tools to address such. Next slide, please. In addition to obviously the project team support and coordination, there's a variety of different QAQC processes and structures. So the ways that we can review data, flag data, both at a hardware level, in terms of an analysis level, increasingly automated systems that we can build and implement that flag data that could be suspicious or concerning, and finding ways that we can do this such that then we meet various requirements, whether those are US EPA or EU Class 1 indicative standards, or any other sort of data quality regimes or performance regimes that arise around the world. And this is something that is obviously a bit of a moving target right now in the global air quality monitoring market for sub-regulatory devices where Clarity operates, but something I very much welcome exploring with all of you, as you consider how we can best implement sensors in parallel with our regulatory infrastructures to address new and exciting air quality management questions. Next slide, please. And again, I think one of the exciting parts is a bunch of statistics here, but simply draw your eyes down to the chart on the bottom left. That I think most of us are aware that low-cost sensors, when they're not properly calibrated, you can see a gray line very faintly down here, which is representative of what most raw particulate data would look like prior to being calibrated, prior to having correction factors applied. And as with many of these systems, et cetera, now as we can get better and better at calibrating and applying correction factors, we can really understand transparently what are these correction factors, how are they being applied, and how are they helping meet my data requirements. In this instance of sensors in Los Angeles, where we're announcing a very large network shortly, for instance, meeting all of the US EPA guidelines for performance for low-cost sensor performance for PM 2.5. So understanding what our goals are that we actually need to achieve and demonstrating that we're achieving those very quantitatively. Next slide, please. Briefly, we do offer an API as well. So not only do we have the ability to selectively download all of the raw data and calibrated data through the Clarity portals in CSVs and traditional sheets, but if we have an interest, programs and customized websites, sometimes air quality models, have the ability to pull our data via API or automated programming interfaces continuously. And that's not just the air quality data, but it's all of the device health and the diagnostics as well. And this gives our partners, in many cases, value-added resellers and cities that are running their own front-end platforms, the ability to provide the same level of quality, the same level of support, the same level of intelligence to their systems as we do to ours. Next slide, please. So briefly, and we'll run through these quickly, one of the most important lessons that we've learned in terms of air monitoring and air quality management that I can't emphasize enough. So next slide, please. You know, it's funny to say, as somebody that, quote, sells air monitors all day, air monitoring alone, and as kind of the point of technology in a box, not solving problems, is simply not enough. And to the next slide, please. One of the things that we've realized, and we've strategized reviewing our hundreds of projects around the world, is that really the success of air monitoring engages, and you've heard me mention several times, the relationship in terms of regulatory management or engagement, the idea of community engagement. So as we think about what our policies are, who they're for, it's amazing how often we learn that the communities, in fact, have knowledge that in some cases the regulators benefit from, and vice versa. And in fact, having everybody in ways that we can structure this relationship becomes much more successful. And then likewise, ensuring that the data analysis and the policy insights and opportunities are open and transparent. So we've really, for instance, to the next slide, please. One more slide, please. Thank you. We've come up with this rough Venn diagram in many ways, built off of our experiences in London, looking at the combinations of stakeholders and seeing that London and some of our other most successful projects have this similar stakeholder consensus that build together. And some of these key factors that not only who do you have participating, but the ways that we can approach our air monitoring projects. I've personally seen too many smart city projects that just want to put things up on poles and they're measuring and they're not exactly sure why, doing something cool. But when we know our objectives appropriately, when we know that we have the right solution for the kinds of air quality management challenges that we're trying to address, when we have the capacity to analyze the data, the engagement with community, and obviously the engagement with regulators as well, who are tasked with the mission of actually intervening, these are some of the key factors that we really see in terms of enabling air quality success and air quality management successes around the world. Next slide, please. So finally, I think one of the things that's exciting is that I often joke I'm tired of deploying air monitoring projects. Today, I'm now deploying air quality management programs. So around the world, we're working increasingly with our partners who may have an air monitoring need, but we're helping make sure and working with them very carefully to ensure that the air monitoring that we would be deploying together is embedded within a more holistic and comprehensive air quality management strategy. That's why working together with partners like Clean Air Asia and many of the other kind of NGOs and data analysis stakeholders around the world, partnering with our government agencies and developing genuine, authentic community engagement practices has been so incredibly successful at scaling the success of the air monitoring that we're deploying. So in fact, that very often I argue the problem with air monitoring and air quality data isn't the question of how much monitoring data we're collecting, but it's a question of how it's integrated in a larger management strategy. So next slide, please. So with that, thank you very much for your attention. Just wanted to say thank you again to all of Clean Air Asia, obviously the Ministry of Environment in Japan, and again to the Institute for Global Environmental Strategies. And very much appreciate everyone's time today. I look forward to the next speaker. Thank you.
Thank you so much, John, for sharing the features, the security sensors, its dashboard, and the overall sensing service provided by your company. It was also very good that you emphasized that indeed air monitoring alone is not enough, and there are many other things we have to work on in parallel. To our audience, again, reminding you that you can continue sending your questions in the Q&A panel on the right-hand side of your screen, and we will address them later on. Dr. Didin?
Yeah, thank you, Ever. So I think we can move to our last speaker before the Q&A session. Mr. Frank Hams is the IQ Air Group CEO since 1996. He leads the IQ Air strategic initiatives and heads its global science and technology team to develop solutions to improve indoor and outdoor air quality. So he spends his time between IQ Air Swiss headquarters, his family in California, and IQ Air's operations and partner around the world. So Frank believes that IQ Air's core competency is to empower people to improve the air they breathe. So Mr. Hams, the floor is yours.
While we are waiting for Frank to be invited back into the podium, Dr. Didin, what do you think so far of the two presentations that we've heard so far?
Yeah, I think it's very interesting actually how the technology can be offered, especially to be added to the recent technology of air quality monitoring data. So, Ever, I think Frank is here right now.
Yes, so welcome back, Frank.
Yeah.
Hi there. Thank you
Yeah.
for having me. I'm very excited to join you tonight for this important workshop.
Yeah.
I will be telling you today about how we can help to bring air quality data alive, because there's a lot of air quality data being generated by regulators, by nonprofit organizations around the world, by scientists, and by even individuals in many cases. So we're very excited to really bring this data all together on one platform. I will be also telling you today about our air quality solutions in terms of monitoring. I will be telling you how it's easy to bring up air quality monitors in a matter of minutes for less than $300 for a measuring point. These are very popular, obviously, for our communities, which are on a budget. And I will also quickly share with you some exciting projects where we've been able to combine outdoor monitoring, indoor monitoring, and air quality improvement with the example of some schools that we've been involved in. Next slide, please. So about IQ Air, well, we're an air quality technology company. We've been doing this for a few years. And we empower the world to breathe cleaner air with three things that we think are very important. It's information, it's collaboration, and ultimately it's technology. And our key areas of competency that we're bringing together is the air quality technology side, the information technology side. So how do we communicate air quality? How do we calibrate, harmonize data? And also the hardware side, how do we bring sensor and technologies together to be able to get reliable data with low-cost sensors? And finally, we're bringing solutions to it too, because we see that many people are seeing there are problems with air quality. Well, what's our next step? Here in the United States, we do hundreds and hundreds of schools, for example, which are located close to freeways or close to refineries and other air pollution sources, so that we're able to make a big difference immediately in terms of air quality while regulators are working to improve outdoor air quality. Next slide, please. So IQ Air operates the largest global air quality information platform. We collect data from 50,000, a little bit over 50,000 air quality monitors operated by governments, NGOs, enterprises, researchers, schools, citizen scientists, and we validate this data. So we're not just a platform that collects that data, we validate it, we harmonize it, we calibrate this data, and we get this data from over 10,000 data sources and contributors. So people who are putting up monitors and organizations. Many of those are governments around the world. we basically learn how this data works. We try to understand these instruments that are basically contributing this data. And then we are looking to make this data work together so that we can present it in one harmonized way. And we publish data from about 25,000 monitors at this moment. It's actually somewhere between 25 and 30,000, depends a little bit, because we validate this data. So we don't just put data up there that's not trustworthy. We will take data down from the platform whenever the reliability is not ensured. We provide this data, we aggregate it to about 15,000 cities at the moment in over 140 countries or regions. Next slide, please. So you can see the red dots here is data from governments. The blue dots is data from private stations. Today on this planet, we're getting close to, we actually have more low-cost sensors now than government sensors that are producing regulatory grade information. And bringing these two ecosystems together is really exciting because it provides some exciting challenges and unique opportunities. Next slide, please. Our data sources quickly, because we're extremely transparent platform where the data comes from. We acknowledge the contributors, we acknowledge the sources, we acknowledge the equipment if we have that information, and we bring together low-cost data. We are a sensor-agnostic platform. While we make some of our own sensors, by far more sensors are being contributed from other manufacturers and other sources. So we bring together a regulatory sensor data together with a low-cost sensor data. And then we use satellite data to help us understand some unique challenges, also to fill in some data holes in certain regions where maybe no data is available yet. And that together allows us to build a whole picture. Next slide, please. So we're using machine learning to basically use the inputs and generate meaningful outputs, including air quality forecasts. Air quality forecasting, again, a very exciting area. We provide air quality forecasts up to 7 days in advance that allow people to plan their day. We consider our platform to be there not first of all for regulators and scientists, but for people. There is about 350 million people looking at our data, either directly on the platforms or within the press who uses our data. So we bring really this data alive, and it's very important for us to make sure that we make this data useful. So many people are now collecting data, but who can see the data and who can do something with the data? This is our mission, really, to make sure that we are able to make this data engaging and actionable. Next slide, please. In order to do that, we need partners. We're collaborating. When you're looking at the partners that we do, we just brought out about 2 hours ago, you can now download our annual air quality report that we are producing in collaboration with Greenpeace, which this year covers 117 countries and over 6,000 cities, where you can rank this data, you can view this data. You can use our app. It's the most downloaded app for air quality that you can find, and then you will see, no doubt, a lot of press generated about air quality. We think that we all need to work together, because I'm always telling people, as long as people are spending more money on a cup of coffee a day than on air quality, I think we still have work to do. So it's really creating this awareness and making people care about the air quality. That's at the heart of what we do. Next slide, please. What's really exciting is to make data actionable. So we contribute our data to the United Nations Environmental Programme, making sure that they are able to use this data and bring, again, more visibility to it, to also challenge governments that may not be doing any monitoring at this moment, to encourage them and to show that this is something that is something that's bigger than governments. It's really something for our entire planet. Next slide, please. This is from the website of the United Nations Environmental Programme, and you can see we're calculating, so this is something that we do together with the UN, we're calculating in real time the global exposure to air pollution. So this is pulled from about 2 days ago, and you could see that about 87% of population was breathing at that moment in time, and it's updated, I think, several times now or even, that they were breathing at that moment in time, 87% of people were breathing air quality that was not meeting the World Health Organization annual PM 2.5 standard. We use a lot of PM 2.5 data because in terms of low-cost sensing, it's really quite accurate from what you're able to do today. And it is also obviously the pollutant that is causing most death on this planet in terms of all the criteria pollutants that you could be monitoring. Next slide, please. An important part of our work is to make sure that we allow people to present their data. So if you're if you're a nonprofit organization, if you're government, you can actually use the platform to show your data, to show your stations, to draw attention to your cause. So creating this transparency for contributors and for air quality sources is, I think, quite important, and allows also the people who are looking at this data to understand who was generating this data. We understand there might be different agendas in some areas. There's people who don't trust government stations in other countries, or other people may only be trusting government stations. We think that transparency allows people to actually understand and engage with this data. Ultimately, bringing all of this data together in one place is what we feel makes a difference. Next slide, please. I talked about the air quality, World Air Quality Report that came out. All of the data that we're collecting, that people are contributing, is actually able to make it into actionable data, which engages people. It makes people care about this. There's interviews going on as we're speaking for India, who's very interested in their ranking this year. This is ruffling some feathers in some countries, but it's engaging people. And I think while there may be good news and bad news from one year to the other, from a city to the other, ultimately, this makes people care about our work. And so I think that's an important aspect, because if we do our air quality monitoring in a quiet chamber somewhere where nobody sees that data, it's not going to help anyone. Next slide, please. So a few words about our air quality monitoring solutions. We have outdoor monitors, we have 2 indoor monitors, we have an app, we have a dashboard, we have 2 APIs, an API where you can actually download the data from your device, for example, and then an API where you can get access to the aggregate amount of data that we're generating. Next slide, please. Our AirVisual Outdoor is a low-cost outdoor monitor that's weatherproof, that can be wall or pole mounted, has a high accuracy, especially for PM 2.5. We're looking in our current measurements in the region of plus minus 10% is what we can achieve in most environments. Has a very accurate temperature, humidity, and barometric pressure. And we can load up, that's quite special on a low-cost monitor, up to 4 sensors in here. We have many of our customers who choose to use, for example, 4 PM sensors, because that creates redundancy in the measurements. And this allows for these monitors to operate for a very long time unattended. Even if one sensor fails, the next sensor takes over. So we basically have a monitoring system that can check up on itself. The unit has Wi-Fi connectivity. You can connect it wired LAN, or with 4G mobile cellular modems. This unit starts at $289, so it's a really, really popular unit with anyone that's on a budget. Next slide, please. You can see here that this unit is really built up in a very modular way. The fact that you can change a module in the field and use these pre-calibrated modules makes it really easy to keep this system up and running. Our goal when we developed this is to allow a system to run for 10 years uninterrupted with no or very little maintenance. You can run power to this up to 60 meters because we're using a PoE, so you can run your data and your power to the unit just with one single line, and that makes it very easy. We're working on more modules over time, so some of the next modules you will be seeing from us is ozone and NO2 and more of that, and so the additional sensor slots can be used for additional sensors. So it's quite an open platform to build upon. Next slide, please. We make indoor monitors. These are quite popular to be used for people at home, in offices. We have a lot being used in schools currently. The beautiful thing with the indoor monitors is that they work together with the outdoor monitors. So you can actually bring the information from the outdoor monitors on the indoor monitors. So you can look in real time at your indoor air quality information and the outdoor air quality information. This is really great for schools. A teacher can know what the outdoor air quality is like, whether children should play outside, have a longer break outside, whether they need to open the windows up. It's all on this one screen here. And obviously all of this data is integrated with our app and our web dashboard. Next slide, please. Accuracy is obviously very important. Here's just one measurement that we made. This is actually from China. We made this in our office in Beijing, which happens to be about 80 meters across to the American embassy in Beijing. And you can see the PM2.5 data is very, very nicely tracking. We just recently completed testing with the Swiss Meteorological Office there. Again, all of these reports are available from us, but we're typically aiming for an accuracy plus minus 10%. Next slide, please. Outdoor installation examples, we can combine the systems with solar. The units have been tested in really extreme weather conditions. You can see here on the left-hand side, snow and ice. Obviously for us in Europe, it's always a big problem, but the same thing is we've operated units in temperature ranges up to 40 degrees Celsius and very, very high humidity levels. And again, this is something that we're constantly working, but these units are working very well. We have some units out there now for over 5 years, continuously working, and we hope to be able to extend that as we're learning more about these systems to about 10 years with very little maintenance. Next slide, please. If you haven't downloaded it yet, please try out our AirVisual app. It's free. It's the most downloaded air quality app in the world. You have it both for iOS and Android, and it shows you the air quality in over 10,000 cities around the world. If you are a regulator, you will see your air quality monitoring station on our app. If you're a low-cost sensor provider and you don't see your station on there, it's very easy. Get in contact with us, and we'd love to put your station up there. We have a validation process, so not every station makes it up on here. We have a period in which we're actually monitoring the device, and we also take off devices if we see that they are located in places that are not giving us accurate information. We monitor for use of for some monitors are being used indoors, for example, if individuals are using these monitors, and we have detection mechanisms to see that we only get outdoor data, and we only get data from sensors that are providing plausible data. Next slide, please. We have a web dashboard which has all the necessary features on there for you to download data, compare data, get warnings from your sensors which are offline. and basically manage every aspect of your sensoring network, whether they're outdoor sensors or indoor sensors. Next slide, please. Finally, we provide air cleaning solutions. Here in Southern California, we are doing air purification for the EPA and for the South Coast Air Quality Management District in really in many hundreds of classrooms. We have developed solutions that work in schools specifically because they are very imperfect environments, often not the most well-maintained buildings, not the tightest buildings. So being able to clean air quality, we've shown that we're able to improve air quality in classrooms by an average of over 90% for PM 2.5, black carbon, ultrafine particles. These are quite effective solutions, and we are seeing that actually test scores and absenteeism goes down, test scores go up once people are breathing clean air quality in schools. Many of the schools that we're serving have outdoor monitoring that they make available to parents, that make available to the community. They have indoor monitoring that lets teachers know when to open windows, when not to open windows, to see whether air filtration is working properly. So this is really can be a very nice solution, not only to show a problem, but immediately provide some solutions to the people affected. Next slide, please. And the effects can be quite dramatic if you do integrated air quality management. This was done actually in Northern California during one of the wildfires a couple of years back, and you can see indoor air quality in a classroom, for example. This was again a school during a wildfire period, was able to go up to about 200 micrograms per cubic meter, or even 300 micrograms. And then the red one is outdoors. Indoors, you can see there's a slight reduction. So building does protect, obviously, from outdoor air somewhat, but that protection was maybe 5 to 10%. And then you can see the blue bar is if you are now able to have the air purification system work during these times, you can reduce air pollution indoors by 95% very easily. And obviously, there's air quality reporting that goes in with a total air quality system. Next slide, please. Super. If you have any questions, feel free to reach out to me and to Dana. Dana is running our running a lot of our outreach efforts, and we'd love to hear from you, and we'd love to give you more information. Thank you so much.
Yeah. Thank you so much, Frank, for your interesting presentation, actually, to share to all of us of your tremendous efforts from your institutions to operate the largest global air quality information platform with more and more information of PM 2.5 air quality data, especially in our Asian developing cities. We hope that the data can be derived as a science-based evidence to derive policy to assess the health impacts due to the PM 2.5 air pollution, and also to achieve the ultimate goal to get the cleaner air in our cities. So, I believe that the session is getting more interesting. So it's now the time for interactive discussion and Q&A session. Please.
Yes, thank you, Dr. Didin. Indeed, we do have some representatives from Vietnam and Philippines, and they are going to give a reaction or comment or ask questions to our speakers. So we will now call to the podium Engineer Neil Ravenna. He is the head of the City Environment and Natural Resources Office of Iloilo City. We also have Ms. Glyza Esparago and Ms. Trisha Golayan of the Climate Change and Environmental Sustainability Department of Quezon City. And we also have Mr. Lu Tan Tai, Deputy Director of Cantho EPA. So I think they are now joining us here in the podium. I think Engineer Neil is already here in the podium. Checking Engineer Neil, can you hear us?
Yes, ma'am.
Hi, good afternoon, sir.
Good
So
afternoon.
we're keen to hear, sir, do you have comments or questions to our speakers?
Yeah, I have a question here. To have an accurate air quality status of a highly urbanized city, is it safe to say that we should have a combination of a stationary and a mobile air quality monitoring system so that you have a more accurate setup for, like for example, a highly urbanized cities which Iloilo City is also qualified as a highly urbanized city, wherein we have a coal-fired power plant, and at the same time we have a sanitary landfill within the city. So I think we need a combination of a stationary and a mobile monitoring system.
I think perhaps we can start with Sean to give insights on this.
Absolutely. So we always say that there's no perfect solution for air monitoring. I think that mobile monitoring can be very interesting if we're talking about either vehicle mounted or bicycle mounted technologies. Admittedly, there often are a lot of challenges in terms of sensing science and how it actually samples, where you're sampling. So personally, if I was addressing that issue, I would actually be looking at a combination of regulatory measurements, stationary sensors, and then working with a lab on composition analysis combined with wind speed and wind direction. So seeing if we could take air samples to actually compare particulate compositions rather than try and do it with a mobile van. Because I believe that might introduce more variables to your questions in some cases than it would answers. That said, mobile monitoring can be really interesting in certain cases for filling in the gaps. So happy to discuss further.
Yeah, thank you for that.
Yeah, I concur with Sean there. I think one of the challenges with doing any sort of monitoring is you need consistency, right? You need to pick up patterns over certain periods of time. And while mobile monitoring can really give you information that maybe is related to mobile patterns, and it really and the granularity is obviously great, right? Because you're moving as you're measuring, you're losing that pattern, right? You don't know what happened an hour before. You will not know what happens an hour later. So having a high granularity of low-cost sensors and then combining them with the necessary regulatory sensors is the way to go. In also from our experience.
Thank you for that information.
Okay, so sorry for that short tech problem, but thank you very much for answering Engineer Neil's question. If you have additional questions, Sir Neil, we'll get back to you after a while. Now, let's also ask our other reactors. Perhaps we can go first to Mr. Lu Tan Kai. Do you have questions or?
Tài thì sao ạ? Không biết là ông có câu hỏi gì?
Tôi có câu hỏi. Thứ nhất thì tôi cũng rất là cảm ơn ba cái bài chia sẻ của đại diện của ba cái công ty. Thì qua ba cái bài chia sẻ đó thì tôi thấy rất là nhiều cái thông tin rất là hay về công nghệ, về phần mềm dữ liệu, cũng như là cái cách tiếp cận về cái công nghệ quan trắc môi trường, đặc biệt là quan trắc môi trường không khí hiện nay của các nước phát triển. Thì câu hỏi của tôi thì nó hơi nghiêng về phía đặc thù của thành phố Cần Thơ của chúng tôi. Thì hiện nay thì chúng tôi cũng có những cái nhà máy đốt rác thải, sinh hoạt, phát điện. Thế thì vấn đề ở đây là chúng tôi cũng đang quan trắc tự động cho các nhà máy này, nhưng mà cũng những cái thông số mà quan trắc thì nó cũng rất là đơn giản thôi. Vậy thì những cái công nghệ mới như các công ty của các ông chẳng hạn như quan trắc được là những cái khí độc trong cái quá trình đốt rác như là dioxin, để mà đáp ứng cho cái việc quản lý trực tiếp, thì mà công nghệ đó có đáp ứng được hay không? hay là cái vấn đề mà tôi cũng đang quan tâm thì hiện nay là đặc biệt là cái việc mà ô nhiễm của những cái hạt vi nhựa trong không khí cũng như là ở biển, thì công nghệ của chúng ta có định hướng tới cái vấn đề này không? Thì tôi cũng mong muốn là đại diện của các công ty chia sẻ thêm những cái thông tin này. Xin cảm ơn.
I was on mute. Apologies for that. I was just checking to our speakers if you were able to hear the translation on time. Okay, so Sean was able to hear it. What about Frank?
I got the last half.
Okay, so just to reiterate the question, Mr. Tai was asking, very unique situation in Canso. They have waste to energy facilities. He was asking about monitoring in terms of SEMS, and also what about the highly toxic compounds such as dioxins and furans, and also microplastics in air. Okay, so I think we can share your insights on this. We can again start with Sean, and then we go to Frank, and of course Dr. Mugasa can also respond through chat, so he will also answer the question through the chat box. Sean?
Absolutely, and great question, thank you. I would strongly suggest using specialized technologies for pollutants such as that. Most low-cost sensors to detect particle diameter for specific gaseous compounds. There are other more expensive technologies for moving into specific volatile organic compounds, hazardous air pollutants, sometimes speciated metals detection, except these are typically extremely costly technologies. There's a lot of people promising to measure a lot of things that they actually can't. So I would really focus on make sure working with Clean Air Asia or others that we can really find technologies specifically designed for dioxin detection or these others. I would personally not deploy my own solutions to solve that problem. Particles, maybe, in terms of generalized smoke, but if you're really focused on these health impacting pollutants, it's really key to find an appropriate tool.
Frank? Yeah. You're on mute, Frank, sorry.
Yes, I concur with Sean on this one. We do a lot of indoor monitoring, and chemicals is obviously a constant source of concern in indoor environments. And the challenge is today that if you're looking for low-cost sensors, you're looking more for an indication, right? Is something present, and is something really changing significantly over time? And then hopefully once you're able to detect something, you give the opportunity, and you monitor certain patterns, you're able to then get involved in more intensive sampling, using sumo canisters, or doing other sampling to basically get you the gas chromatography that you need in order to analyze these samples. So typically we use, we try to see that we establish patterns where you're suddenly able to see, is something changing that I'm not expecting? And that allows you to then basically be able to bring in the more expensive equipment and the more expensive processes to be able to monitor and see whether this change is something that you should be worrying about.
Okay, I think shall we hear response from Dr. Misaka?
Hi,
Okay, so I think we will try to invite the next reactor to represent the Quezon City of the Philippines, Miss Glyza Esparago and Miss Trisha Golayan. If you are here, please, if you have questions.
Oh, I think Dr. Didin, if
Yeah.
they perhaps they're having some technical difficulties
I see. Yeah.
while we wait for them, perhaps we can read some of the questions in the Q&A box, because we also have some interesting discussions there. Dr. Misaka is actually answering some of the questions in there.
Yeah. So maybe I'll try to read the question from Yosu Morinaga. To all speakers, what are the major technical problems, challenges you are facing in monitoring air quality? Any regional issue in Southeast Asia and India on the top of global challenges? So I think we can start to hear the response from Dr. Misaki on the question from Yosu Morinaga.
Thank you for the question. Japan is also moisture and humidity. That's why same problem happen. So we have to collect the data and I cannot say.
It's okay, Misaka-san.
Yeah.
I think if you want to elaborate, you can do it in the chat, and then we'll read it out here. But I think Misaka-san was also emphasizing that also even in Japan, temperature and humidity is really a big problem. He was saying that we do have to do data corrections. So I think
Sorry.
no problem. It's okay.
No problem.
Completely fine,
Thank you so much.
Misaka-san. Yes, thank you so much for that answer, and we are very appreciative. Also, he answered a lot of the questions already here in the Q&A. What about Frank? What are the main challenges that you faced so far?
I think that the challenges that we're seeing generally in the market space now, with so many different low-cost monitors coming on the market, is what will happen with these monitors over time, right? Sensor drift, I think, is one of the big concerns that we can see. These monitors may well be working very nicely for the first 6 months, maybe the first year if you're lucky. What happens after that, right? And how do you make sure that you can detect these different failure patterns that we can see? And this is one, I think this is a challenge that will hit everyone at some point, especially for the systems that are maybe not running on a service like Clarity, where maybe people are operating them sort of by themselves, right? And are basically trusting as long as the system is giving you something back that is reliable, and that might be publishing this, right? So how do you detect this over time? I think that's a big challenge. So that's where obviously it's quite important to have a lot of data, so that ultimately you're able to compare this data among the different networks. We can see that this works quite well. This is where machine learning can also come in to obviously get rid of some of the data that are outliers, right? In this whole challenge. I think the other question that's coming up sometimes is obviously, as the methodology may be different with different people putting up these sensors, is are you capturing something that's representative enough, right, of your environment? You know, here in the US, people like to grill, right, on a Sunday afternoon. Is this something that is relevant a block down the street, right? So how do we deal with these sort of things, especially as we have more and more people deploying these sensors? I think these are some of the challenges that will be important, and that even people putting up regulatory monitors will be obviously needing to address as people in the community will challenge them with data that they're collecting or that they're seeing on other people collecting in their community. Yeah.
Sean, perhaps you want to add to this?
There's been a lot of great points raised. First and foremost, I'll agree with you, Frank, that the citing questions is a huge challenge. It's part of the reason that Clarity spoke very specifically that we work with community groups or government agencies, particularly around developing citing plans on behalf of communities, but not having the communities deploy them themselves always. So we work very carefully to find that intermedium where we can work with the community groups and with the government agencies to ensure the data that we're collecting is really answering those questions. We have seen a lot of instances of sensors deployed where the data would seem to suggest something, but when you look into where the sensors or how the sensors were placed, it can be very misleading. I would say, yes, humidity and temperature challenges across the board in terms of sensors, particularly in Southeast Asia, and as well as the sensors' maturity themselves. So some of the electrochemical sensors for certain gaseous pollutants, ozone, nitrogen dioxide, varying states of maturity. SO2, H2S, I'm not terribly impressed with too many cross sensitivities, for instance. And then likewise, I think, Frank, to your point too, in Southeast Asia, the pricing structures are challenging. People want to buy them as a product, not as a service. But just like a car, we should expect that there's maintenance and operational costs and all the things to keep these tuned in a way that keep them useful. So it's, I think, very important that as, from a government perspective, we're thinking about this again as something that takes time and investment. It's not pay for it once and we've solved all our problems. But just like your regulatory monitoring infrastructure, it's an instrument that requires tuning and maintenance as well.
Yeah, so completely agree, Sean. So thank you very much. Even Dr. Misaka also emphasized in his replies in the Q&A that's why you also have to have reading from the official or the reference level instruments and use the data as well to compensate or to correct for sensor data. We have a very interesting discussion, but unfortunately, we have very limited time. We will share to our participants all the responses as well in the documentation. And Dr. Didin, what do you think?
Yeah, Evan, I think it's a very interesting session actually, but I'm afraid that we are very close to the end of the sessions. So thank you again for your active participations and also for the reactors who represent the cities in Southeast Asia. So especially thank you so much, Dr. Misaka, Shen, and Franz for joining us and also for sharing more about your technologies. Uh, but be aware for everyone that we will have a 10-minute mobility break, but please be back and join our last session. The last session is co-innovation and financing for technology cooperation in Southeast Asian cities. It will be started on 2:20 p.m. the Philippines time. So thank you again and hope we can see you again in the next occasion.
Thank you
Have a
very
good day,
much. See
everyone.
you. See you in the
See you.
next session.